When I say that when you come to multicore world, you are 10 years ahead, Peter Coggy, multicore world 2016.
Oh.
Or 2017 or 2015, something like that.
Yeah. He just published a nice book, by the way, about new technology. So you need to get him back.
Didn't quote me. Yes, please. Rude, Andrew, Carolina, yeah, please.
Thanks, Jeff. Very interesting. I had a question, and then 5 minutes ago, you blew away my question by another one. When you say that the generated code, in some cases, is more efficient than a vendor library, the devil's advocate in me says, was that library so bad then? Because we know that in general, especially BLAS, is pretty well handled by compilers as well. So I know it's early work, so I'm just very curious one day to hear the answer.
Yeah, that's an interesting, there's a lot of details there that I don't remember all the details for the individual calls, but there were some things we saw where, especially when you're going across architecture, for example, you'll see the AMD user library didn't perform as well as the CUDA library, which makes sense. NVIDIA's been working on their library for 15 years or more, right? And AMD not as much. What the LLM potentially can do is pick up optimizations in the other libraries or the other things that it parses and apply those to these new architectures that maybe other people just haven't applied yet, and you get a speed up there. And we have some text in the paper that describes what some of those discrepancies are. But it's very interesting. I was surprised by the results.
Yeah, thank you,
Andrew.
True.
I'm interested in the point about correctness. How are you measuring correctness? Is it correctness as a percentage of the code, or correctness as a percentage of getting the right results in certain regions of parameter space?
Right. Yeah, so the table I showed, was a little bit awkward. We defined our own numerical metric, and it meant different things, like dot or 2 meant that it may be compiled, but we couldn't get it to execute. And then 4 meant that it compiled and ran, but it didn't pass the unit test. And then 6 meant it passed the unit test, but when we tried to execute it, it blew up, right? Or things like that. So it's not precisely a linear metric, right?
So it's not a measure of numerical correctness or numerical...
Correct. Yeah. You're right.
Florina, Bo, Ran.
So I think that is a measure of success rather than correctness.
Yeah. Right. Yeah, okay. That's a good way to put it.
I'm very interested, so thank you very much for your talk. I like executive summaries, and summaries really just maps out what's coming. I would like to ask you about the last part, about the AI could be the answer. Mm-hmm. I'm wondering the same thing, and I'm trying to get started a project that is looking like yours, Chat HPC, and I was immediately trying to access the website as you were presenting, but I was not able to. It requires a login that is related to ORNL.
Ah, okay.
So is the project open source, or?
So we have a weekly call and have been working with people to get them in. So if you want to send me an email,
absolutely,
we'll add you.
I'll do that.
We've got a list of about 10 external collaborators right now. So it's not closed source, but it's not hanging off the web at the moment.
Okay, good. Thank you.
Sure.
So it's DOE with a G in the middle.
What's that?
Next question.
No nuclear questions? Or
why I'm so surprised. There is a guy in the back saying,
we're going to have an SMR. I love this. I mean,
Rude in the back. Rude.
Yes.
Good.
Well, now that first question comes, that's about the hardware part, and it's just more like an observation than a question, is that it took a long time to get computer architects to give us hardware counters in sufficient detail.
Right.
But what I'm missing is on the energy side. Wouldn't it be nice to not only measure your flops and whatever you have, mm-hmm. but also at the same time see how you're doing energy-wise so you can balance the two? And that's going to be a very difficult discussion with hardware architects, I guess. But maybe you guys, with all your power, can help convince them,
Quote.
or do it yourself
Yeah.
in your own hardware.
Well, so I got a lot of things to say there. So there are some power measurement features on GPUs and things like that. The question is how fine a granularity is it, right? You can't measure uninstruction, and in some cases, even if you could, you may not measure the data movement caused by that instruction, like a cache miss or something like that. And so that is, what we ultimately need to be able to do. Now, the other question is, do we have enough data, enough information to make decisions about our code, how to optimize our code and things like that? That's an open question. The counters are always great. I hate it. They put them in sometimes and take them out other times. And you're just basically doing a design of experiments run every time you do optimization, because you tweak things and see if it improves it or not, and then try something different, right? It's human simulated annealing, if you will, right? And so, but I agree with you.
Yes. Let's say thank you.